All right, guys, here's part three. Now we're switching gears. We're going to jump into some trigonometry, and so a couple things right before we start. Trigonometry is based on similar triangles, and so we'll still be dealing with ratios and solving ratios and that, and the other. But also don't forget things like sine, cosine, and tangent are in play, including arcsine, arccosine, arctangent, those inverse functions. You will probably be using your calculator for at least part of this. So word to the wise, make sure that your calculator is set to degree mode. DEG. If you're using one of our graphing calculators or maybe one of your own, I would actually just do a reset and then set it to degrees. So like second plus 712, uh, and then uh, make sure you clear all the RAM, go to the mode, change it to degrees. All right, so let's get rolling. There it is. Okay. So which one of the following setups are incorrect? And the keyword here is incorrect, based on the picture given. So we're asked to deal with sine, cosines, and tangents. So let's just take a moment, if we could, and just remind yourselves which is which. You might know this, but this is good for me too. And if you don't know it, maybe it's a good thing to write down your notes. Um, if we are dealing with sine, remember that is the same as opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Remember, you were probably given a mnemonic device to help you remember this, which was like SOHCAHTOA. SOHCAHTOA is designed to help you keep these ratios straight, and those should just be something that is in your head the whole time. Okay, so let's go ahead and attack this. The best way to attack this is probably just to go really honestly through one on one and see which ones are work and which ones don't. So sine of 21 is equal to 4 over x. Please recall this means that that is going to be our reference angle, and this is going to be our actual ratio in our triangle. So sine of 21 means we're putting our reference angle right here, and sine, of course, is going to be like opposite over hypotenuse, and let's see that is actually 4 over x. Um, the right triangle is here. I'm sorry, the right angle is here, means that x is your hypotenuse. If we're sitting on 21, 4 is going to be our opposite, and so the sine of 21 opposite over hypotenuse should be 4 over x, which it is here, meaning that's actually a correct setup. So it's not the thing that is wrong. Let's go to the next one. Sine of 69 equals 6.7 over x. Now you may say, wait a second, 69 is not actually listed in our triangle. But please recall that all the angles of a triangle have to add to 180 degrees. And so that makes this angle 69 degrees. So we do have that angle. Now sine again is opposite over hypotenuse. And so we're just confirming that it should be 6.7 over x. Well, if we're sitting at angle 69, the opposite side is 6.7. The hypotenuse is still x, which means that our ratio opposite over hypotenuse should be 6.7 over x, which is actually, again, what they provided for us, so that's not the incorrect one either. Let's keep going. Tangent. Call tangent is OA, opposite over adjacent, and we're looking at the reference angle of 69 again, so sitting here 69, opposite is 6.7. Adjacent is one touching, and that's not the hypotenuse, which should be 4, and so that ratio is good as well. Now that, of course, tells us that the final answer is probably going to be our answer. It's the one that's incorrect. But let's go ahead and double check it anyway, just for a little extra practice. Cosine is adjacent over hypotenuse, and we're referencing 21, so we're referencing this guy right here. Adjacent is the one that's touching it, so that should be 6.7. And then hypotenuse for cosine should be x. And if you look, they're using 4 over x. It looks like they mistook sine and cosine. So this is our answer right here. All right, question 2. Fill in the blank on the following problems. Oh, these are my favorite ones. Again, because we have to figure out reference angle or maybe a ratio. So let's go with this first one, sine of blank. And so this is asking for an angle. A referencing angle equals 13 over 7. Well, or 13.7 over 15. If you recall, sine is opposite over hypotenuse, so which means whatever angle we're looking for, it's across from 13.7 and uses 15 as a hypotenuse. So which angle is across from 13.7? Well, here's 13.7. Here's the angle that's across from it. So this should be 66.35. Okay, this one tells us the angle. We have to come up with the right ratio. So cosine, recall, is adjacent over hypotenuse. They want to use 23.66 as the angle. Now again, think about the triangle sum theorem. That is 23.66. Adjacent to that would be the one touching it. That gives us 13.7. Hypotenuse is used, and that's still going to be at 15. Boom. All right. Tangent of some angle. Again, we're looking for the angle is 6 over 13.7. Recall tangent is opposite over adjacent. So we're looking for something that's across from 6 and touching 13.7. That's going to give us, I think, 23.66. That's across from 6 and it's touching 13.7. So 23.66. All right. All right. Just a few more questions here. We need to find the length of the missing sides for the questions below. So we're going to have to do a little trigonometry here. Now, the first thing I like to do when I attack a problem like this is go ahead and write in the missing angles. We're probably not going to use them, but it's not a bad idea to give us it out if we need it. So if all the angles add up to 360 degrees, and I already have 62 of the angle there, this one should be 28 degrees. Let's see. It says a missing side, so I'm going to assume they mean both of them. So I'm going to relabel those things. I'm going to call this side. Oops. I'm going to call this side X. I'm going to call this side Y, just so you know what we're solving for when we're solving for it. We'll solve for X first. It doesn't really matter which, honestly. It's just one I saw first. So I'm going to solve for X. So that means I'm going to use sine or cosine tangent, which means I need a reference angle and I need to pick the right ratio. Although I solved for 28, safety in my heart always says go with the one that you were given. So I'm actually going to use 62 as my reference angle. And I need a side to reference. I have 7.4, and I'm trying to solve for x. Now, if I'm standing at 62, 7.4 is going to be my opposite side, and if I'm standing at 62, this is going to be my adjacent side length. So now we can go ahead and set up the trig sentence to solve. To solve for x, we're going to use a tangent value referencing angle 62, which is equal to opposite over adjacent, which gives us 7.4 over x. Now this is a standard kind of setup for a cross multiplication problem. So let's go ahead and do that. If I cross multiply, I'll end up with x times tangent of 62. Is equal to 7.4. Now just straight up algebraic solving for x now tells us that we need to divide by the tangent of 62, which will cancel that here. And so if I want the value of x, I'd have to solve for this guy. Let me go to my old calculator. Okay, so 7.4 divided by the tangent of 62 gives me an x value of approximately, because I do have to round this one, 3.93. Okay, so I'm going to write that up here as well, 3.93. Now, if I look at this, it makes sense that 3.93 is my answer. At least it fits what I know about triangles. 62, the angle 62, is across from 7.4. The angle 28, which is of course smaller than 62, should be across from a smaller side length, which it is. If that number would have been bigger than 6.4, that's a red flag telling me I did something wrong. But it's not, it fits, and that allows me to move on and go ahead and solve for y, which I'll do now. Same routine as before. I need to pick an angle. I need to pick some side lengths in the right ratio. I'm going to pick 62 again as my reference. I'm going to use 7.4 again for my known side length and then solve for y. If I'm standing at 62, 7.4 is still my hypotenuse, or sorry, still my opposite side. Y is actually my hypotenuse value, which tells me that I need opposite over hypotenuse. That's screaming for sine. So we can set up our sentence, sine of 62. is equal to the opposite 7.4 over the hypotenuse of y. And now I'm going to go through a very similar solving routine as I did in the previous example. I'm going to go ahead and throw this over 1, cross multiply. Y times the sine of 62 is equal to 7.4. Okay, now if I divide by a sine of 62 on both sides to cancel that, that'll give me a y value that's equal to 7.4 divided by the sine of 62. Now if I go to my handy calculator here, let's see, 7.4 divided by 62. That gives me an approximate value for y of 8.38, which I'll go ahead and write up here as well. Now, again, knowing what I know about triangles, this makes sense because 8.38 is the largest side length out of the three. And since it's across from the largest angle, since it is hypotenuse, it should be the biggest. And it is. So I should have pretty high confidence that that worked out well. All right. Let's go again. So x, that's going to be y. If that's 74, that tells me my other angle has to be, let's see, 16. 70, 90, yeah, it's going to be 16. So again, knowing what I know about triangles, trying to set up kind of my answers ahead of time, I do know that y has to be smaller than x, and both those numbers are smaller than 12. So that gives me a framework for when I'm working these problems in the future, to make sure I'm hitting those kind of basic guidelines. So since 16 is the smallest angle, y is the smallest side, and they both have to be smaller. So x is going to be the biggest side, but x has got to be less than 12. Let's solve for them. All right. So let's go ahead and solve for x here. To solve for x, I'm going to use 74 as my reference. 74 makes x the opposite side. I was given the hypotenuse side to begin with, which tells me I'm using sine. So the sine of 74 is equal to the opposite, which is x. Hypotenuse, which is 12. And now let's do some algebraic solving. So cross multiplying gives me x going one way, and then 12 times the sine of 74 or the other cross, which is something I can type in directly. So let's see, 12 times 74 sine of gives me an approximate value of 11.54. Again, this fits what I know about the triangle. Since it's across from the biggest angle, it's got to be the biggest side length, and it is. And so far, it's still lower than 12, which is good. Let's put and solve for y. All right, so same kind of thing. I'm going to pick 74 as my reference. I'm going to use 12 as my known side. Y, however, is my adjacent side in all this. So if I have adjacent and a hypotenuse, it's screaming for me to use cosine. So cosine referencing angle 64 is equal to the adjacent side, which I don't know is y, and the hypotenuse is 12. So algebraic solving again, cross multiplying, y is equal to 12 times the cosine of 74, which gives y an approximate value of let's see, I got 3.31. And that fits directly into my framework that I established earlier. Y is across from 16, which is the smallest angle, making it the smallest side length. 74 is across from the biggest side length, and that biggest side length is less than 12. So I have high confidence this is good. We're going to move on. Okay. So let's see. We've got to find x, which I'll label right now as hypotenuse because it's across from the right angle. And we also, in our journey, have to find y, which is depending on my angles. If that angle is 41, that makes this one, let's see, 49 degrees. 49 plus 41 should equal 90. Yeah, so we're good. Let's go ahead and set up our solves. 41 is the angle I've been given, so I'm gonna be try to be consistent and go ahead and use that for what we're gonna solve today. Let's solve for x hypotenuse first. So I'm trying to find the hypotenuse. I was given 15. Now, if I'm standing on angle 41, 15 is my adjacent side length. If I have the adjacent and the hypotenuse, if I have the adjacent and hypotenuse, then I 100% should have, what's that, cosine. So cosine using the reference angle of 41 is the same thing as the adjacent side 15 over the hypotenuse, which is x. Cross multiplying, I have x times the cosine of 41 is equal to 15. So if I divide by cosine of 41 on both sides, of course, those are canceled. So x should be approximately equal to that value. And that value is 15 divided by the cosine of 41. I have 19.88. Now, being the hypotenuse, this should be the biggest side length. Ergo, it should be bigger than 15, and it is. So it's a number that I can believe in as far as validity in my answer. Now let's go ahead and solve for y. I'm going to use 41 again. To 41, y is the opposite side. I've been given the adjacent side. Now this is screaming for me to use tangent then. So if I'm looking at the tangent of 41, that's equal to OA, so it should be opposite, which is y, adjacent, which is 15. In cross multiplying, I have y is equal to 15 times the tangent of 41, which gives me approximate y value of 13.04. All right, so let's go and get that in there. So 13.04. Now this is good. 41 smaller than 49, so that side should be smaller than 15, and it is. 13.04 fits right into our scheme. We can trust it. Let's move on. Okay. So a couple application trick problems. A 25-foot tall flagpole, casts a 42-foot shadow. At what angle does the sun hit the flagpole? Well, the very first thing we should do is draw this thing. So let's see, we have a 25-foot flagpole, so that measures 25 feet. Casts a 42-foot shadow, that's 42. There's a sun in here somewhere, so, sun casts a shadow like that. And they're asking at what angle does the sun shine or something. At what angle does the sun hit the flagpole? So this is kind of a deceptive question because it's kind of difficult to discern maybe what angle you're looking at. So the way I interpret this question is that if I'm standing on the ground and I look up at the sun, that's the angle at which I'm looking. And so that tells me it's angle elevation, which is this guy right here, which I'll call theta. Recall if we're solving for theta, that means we're using the inverse function for sine, cosine, or tangent. And if I'm looking at theta, I have 25 and 42, which is opposite and adjacent. So I'm using the inverse tangent function for this one. So the inverse tangent, of my tangent function, which is 25 over 42, gets to be theta. Now this is not something I have to do any more than actually just go ahead and calculate. Let's see, so 25 divided by 42. And we'll take the inverse tangent of that function, and that tells us theta is approximately 30.76. All right, let's see. Last one for this set, and I know this has been a long set, guys. I'm feeling it too. A 5 feet long Met ladder leans against a wall with the top of the ladder. Let's draw that. So let's see, we have this wall and we have this ladder. And it's a 5 meter long ladder. Leans against the wall with the top of the ladder being four meters above the ground. And so that tells me this distance is 4 meters. What is the approximate angle at which that the ladder makes with the ground? So we want this angle because that's the ground, that's our theta. If we look at the two pieces we've been given in relationship to theta, we have the opposite, which is 4, hypotenuse, which is 5. So if we're given opposite and hypotenuse, that leads us to wanting to use some form of the sine function. But since we're solving for the angle, we're actually going to use the inverse sine function. So the inverse sine function of the sine ratio, which is 4 over 5, is going to be our theta value. So if you go to our calculator and look for the inverse sine value, that's going to be approximately 53.13. And so that's going to be our value, 53.13. Which is not outrageous. I mean, 53.13, that's about reasonable. It's not, so it's nowhere near 90. 4 and 5 are fairly close to the same number, so again, just under 60 sounds about right. Alright guys, that's our first page of trig. This is part 3. I'll see you in part 4. Looks like we get to do a little more trig and some balloons. Alright, so I'll see you there.